I just, as a repetition, would project this slide. I'm sorry if this is the Hungarian version, but the drawing itself is the same as you have in your lecture slides. It's in English. So first the coverages. Outermost coverage of the kidney is the renal fascia. Then we have an adipose tissue capsule, and then a fibrous capsule here. And this is a kind of coronal sectional view, just like the section what we are going to look at first. Just underneath the fibrous capsule, the parenchyma start, and this kind of color is the cortex, which is one part of the parenchyma. The other part is the medulla, which is this kind of color, and it is present in the form of truncated pyramids like this. The human kidney is multilobar, therefore we have multiple pyramids because each lobe contains one pyramid, plus the surrounding cortical tissue. And the tip of this incomplete pyramid faces one of the minor calyces, like here or there, and minor calyces unite to form a major callus, and major calyces unite to form this dilated territory, which is the renal pelvis, which is getting thinner and thinner as it leaves the kidney at the hilus and it continues into the ureter. This kind of concavity, what we call hilus, is the territory where ureter leaves, and also where we find the renal artery and renal vein. And you can see that in this territory, the adipose tissue capsule is invaginating towards the inside of the kidney. These territories are called sinuses. And the other thing is that we define the macroscopic unit of the kidney, the lobe, which consists of one pyramid, plus the surrounding cortex, this superficial part, which is just underneath the fibrous capsule, plus laterally part of these so-called renal columns here and there, renal columns where the cortical tissue invaginates deeply. And in the midline of these renal columns, we have special blood vessels, interlobar artery and also interlobar vein are present in the midline of these renal columns. Not everywhere you can see both, but in reality both are present. And these so-called interlobar vessels define the lateral border of the kidney lobe, in the center of which we have the pyramid. So if I want to draw around the lobe, if I start here, go along the interlobar artery, go to the fibrous capsule, include this superficial cortical tissue, and go down to the neighboring renal column in the midline along the interlobar vessel, and then close the line. And actually, in the section what we are going to look at, we will see one part, a major part of one kidney lobe. Okay, this is the introduction. So, from the coverages, we can see only the fibrous capsule here. So, the outer adipose tissue capsule and renal fascia are not present in this section. Underneath this fibrous capsule, we have the parenchyma, and this part of the parenchyma, what we can see here, is the cortex. Oh. Now, here down in in the other side, we have the tip of a papilla. A papilla is the term what we use to define the incomplete tip of the pyramid. And this cavity here is the minor callus, cavity of the minor callus. And this adipose tissue here is something which belongs to the renal sinus. Now, on the other side, well, the papilla is which faces this cavity.
All this?
Well, it's difficult to tell. The papilla is lined by simple columnar epithelium, which is yeah, that's a problematic issue here, because maybe here this is one of the best territory, more or less believable that this is simple columnar epithelium. So obviously this is also belongs to the papilla, but maybe this one also.
Thank you.
And on the opposite side, once we are here, the lining epithelium of the minor callus is urothelium. Here on top you can see umbrella cells as a proof. So the papilla is in the opposite side, lined by simple columnar epithelium, and on the other side, which belongs to the minor callus, is lined by urothelium. Other layers of the minor callus include the lamina propria, no muscularis mucosae, but we have muscularis externa, and the outermost layer is adventitia. These are the layers of the minor callus.
There is no muscularis mucosa, right? There is no muscularis mucosa.
No. You know, the parenchyma is divided into two major parts, cortex and medulla. Cortex is the territory where which starts here, just below the fibrous capsule, and extends downwards until as far as this kind of line here, which is the cortical medullary border, and below we have medulla. But this border is defined by presence of certain blood vessels, like this one, that one, that one, or that one. These are the so-called arcuate vessels. This is an arcuate artery, also this one and that one, but this is an arcuate vein. So one way how we can define the border between the cortex and medulla is where we can find these blood vessels. If we go back to the drawing, you can see this arcuate artery here at the base of the pyramid, also the arcuate vein. These are branches of the interlobar artery and interlobar vein.
There is a huge artery below them. Is it? If you look down to the right.
Yes, this is what is coming now. This is an interlobar artery. So this is the territory of the renal column, hardly visible. This is artificially cut. On the other side, you cannot see renal column. Okay? So this is not a complete lobe, therefore, because the lateral boundary of the lobe is where we have these interlobar vessels, where we have this vessel, but on the other side, we don't. So part of the other side is missing. So this is part of a kidney lobe. And this renal column, also cortical tissue, because you can see here renal corpuscles, these spherical structures, which are only in the cortex. They are not present in the medulla.
What is it again?
Renal corpuscle. Renal corpuscle.
So it's the Bowman's capsule?
We will analyze this, but
Okay.
one by one. First, the major structures at lower power. Okay, so as you can see, the cortical tissue is this thick in most places between the fibrous capsule and the arcuate vessels. Below we have the medulla, and in this medulla we really don't have any renal corpuscle. But at the side here, the cortical tissue extends deeply, and you can see renal corpuscles at this level as well.
Only in one side, right? Only in this side?
Yes, because the other side is not
It
complete.
doesn't contain.
It is also there, but it is not included in the section because here it is artificially cut.
We can understand this is the cortex with the interlobular artery, right?
This is the interlobar artery.
And this is in the cortex.
This is in the renal column. Now, the cortex can be further subdivided into two parts. One part is where we can see these regular kind of arrangement of tubules which are running parallel relative to one another, forming line-like organization here, here, or here. These structures, this is the thickness, or this is the thickness. These structures are called medullary rays, which are oriented perpendicularly to the outer surface, and also perpendicularly to the cortical medullary border. So medullary rays, collection of medullary rays, is one part of the cortex. The other part of the cortex is what we have between medullary rays, which is a more irregular territory called cortical labyrinth. Cortical labyrinth. It is more like labyrinthic because here the kidney tubules are convoluted, whereas in the medullary rays we find the straight parts of tubules. That's the major difference why at low power the irregularity is markedly different. Medullary rays are quite looking regular, cortical labyrinth looks like irregular. Now the cortical labyrinth contains the renal corpuscles as well, in addition to renal tubules, the convoluted part of the renal tubules. Convoluted part of the renal tubules. Curvy part, convoluted, curvy part. And we we can divide the cortex into two parts in a different way as well. If we go to the superficial part, you will find that in this territory you cannot see any renal corpuscle, and also you find that medullary rays don't extend to this territory. So this territory, this most superficial part of the cortex, which lacks renal corpuscles, this is called cortex corticis. This is Latin, means cortex of the cortex. Cortex corticis. So here we only have convoluted tubules, but no renal corpuscle. Okay. Now, let's look at the structure of the renal corpuscle. Here is a drawing, maybe. Maybe take this one. So, the renal corpuscle has two major parts. The inner part is a capillary meshwork called glomerulus. And the outer part is a capsule around it called Bowman's capsule with capital B and W. As a capsule, it has a cavity, which is here. This space is called urinary space, or you can call it cavity of the Bowman's capsule. It is called urinary space because the ultrafiltrate accumulates here, a fluid which is derived from blood circulating in the capillary. And we are talking about a capsule. So as a capsule, it must have a wall, an outer wall here called parietal layer, which is lined by a simple squamous epithelium. This is what we looked at in first semester as an example for simple squamous epithelium. And there is an inner layer called visceral layer, which is lined by cuboidal cells called podocytes. In addition to these, a renal corpuscle have two poles. A vascular pole, where we have an afferent arteriole, which brings blood to the glomerulus, and an efferent arteriole, which drains blood from the glomerulus. Afferent and efferent arterioles. Where we have these, that's the vascular pole. Where these two vessels are.
Is it possible to differentiate them?
No, with hematoxyliosin you cannot. You need either immunohistochemistry or, for example, PS reaction. Opposite, we have the urinary pole. And urinary pole is the territory where the cavity of the Bowman's capsule becomes continuous with the very initial part of the tubular system. So this very initial part of the tubular system is the proximal convoluted tubule. So at the urinary pole, the urinary space and the proximal convoluted tubule becomes continuous. Therefore, the ultrafiltrate can flow away, may flow into the tubular system. So we have a renal corpuscle here. This is what I like to show because although all renal corpuscles have efferent and efferent arterioles, but usually they are not visible because they are not in the plane of section. But this is a lucky situation where at least one of these arterioles are in the plane of sectioning. Okay? We cannot tell whether this is the efferent or efferent arteriole, but as it joins here, it defines the territory where the vascular pole is. Okay? And it is also lucky, even more lucky, because we can see the urinary pole opposite, where this urinary space becomes continuous with the proximal convoluted tubule. So here we have the urinary pole. So this is a very lucky plane of sectioning because we have the urinary pole included and we have at least one of the arterioles included. In most cases, neither of them are included in the plane of sectioning. So this is the glomerulus, obviously. And you can see the parietal layer of the Bowman's capsule lined by simple squamous epithelium. And the inner wall, the visceral wall, is lined by a cuboidal epithelium. These cuboidal cells with euchromatic round nucleus, these are the so-called podocytes. These podocytes line the visceral layer. Yeah.
When you say the visceral layer, do you mean surrounding the afferent or efferent blood vessels?
No, these are which line the cavity of the Bowman's capsule, the outer wall and the inner wall.
Yeah, there are vessels that go inside. They are.
Well, inside here we have capillaries.
And what's the other structure that collects, like, only capillaries?
Inside here we only have capillaries as blood vessels, as a continuation of the efferent arteriole, which is drained by the efferent arteriole. It is interesting that the drainage is also arteriole, and the reason is serious because this is one situation in the body when after blood is going through a capillary bed, through the glomerulus, it remains arterial in nature.
So what are the podocytes on what structure?
Podocytes, we will talk about them a bit later more intensively. They are involved in creating the filtration barrier as well, but for now I just mentioned that they create the lining of the visceral layer of the Bowman's capsule. Cuboidal cells with euchromatic nucleus. The parietal layer is lined by a simple squamous epithelium. That's all I mentioned so far. Okay. Now, inside the glomerulus, we have obviously endothelial cells like this, which line the capillaries, or that one, squamous heterochromatic nuclei. But you can see other kind of nuclei because there are at least two other kinds of cells inside here. There are podocytes, like cuboidal euchromatic nucleus. But in addition, we also have so-called mesangial cells. Mesangial cells. Oh, sorry, this is Hungarian. So these brown cells here inside the glomerulus, these are the mesangial cells, which can phagocytose, give structural support, have secretory activity, and also contractile and therefore including blood pressure regulation inside the glomerulus. We cannot really distinguish these cells in the hematoxyliosin stained section, but we need to know about them. So here is the afferent arteriole, efferent arteriole, vascular, urinary pole, and vascular pole. Okay. Now, let's talk about podocytes.
The podocytes are not located just in the vascular wall.
No. They are everywhere in the glomerulus because as you can see here, a little curvy part of the capillary meshwork of the glomerulus. These podocytes, these yellow cells, have processes, and these processes, primary, secondary processes, and these processes cover the outer surface of the capillary. And these podocyte processes, called pedicles, interdigitate, form a zip-like structure. So neighboring podocytes processes interdigitate, forming a structure like this, like a zip, and cover the outer surface of the capillary.
Sorry, you mentioned it forms a connection to each other and it covers the capillary.
No, I didn't, there is a connection, but I didn't say that because it is not really a connection. Molecularly they are connected, but
Do they have a like fenestrated thing for the...
okay, it is coming. This is still the podocyte. Fenestrated nature is the nature of the endothelium which lines the capillary, which comes now. So here is the endothelial lining, and you can see these pores, which are the fenestrae, because the glomerular capillary is lined by fenestrated endothelium. So through the cytoplasm of endothelial cells, there are tiny holes with diameter something like 70 to 100 nanometers. Okay. And there is no diaphragm. Usually in a fenestra we have diaphragm, but here the diaphragm is missing. And here we need to talk about something called filtration barrier, which is a histological barrier which separates two compartments, just like any histological barrier. So we need to discuss which compartments are separated. So the two compartments are